My project was about exponential growth and how it is related to population growth. My problem was, in 1918, the population of Arizona was 320,000. The percent growth rate of population per year is approximately 3.152%. Part 1, find when the population of Arizona will hit the 10 million mark. Part 2, find the projected population of Arizona in 2019. The first way we will solve this problem is to use an equation. To set up an equation for this problem, we can use the base formula for percentage growth. It is as shown here. P of t is equal to P sub 0 times 1 plus r to the power of t, where P sub 0 is the initial value, r is the rate of growth as a decimal, and t is time in years. For part 1 of this problem, we are asked to find when P of t is equal to 10 million, which means we are solving for t. We can substitute 10 million for P of t, 320,000 for P sub 0, and 1.03152 for the growth rate. This is because r must be a decimal, so we must convert 3.152% to a decimal by dividing by 100, then adding 1 to get 1.03152. Then we can solve, as shown, to get 111 years after 1918, which means that in 2029, the population of Arizona will hit 10 million. Part 2 of this problem asks us to find the population of Arizona in 2019. We are given the value for t, which will be 101, as 2019 is 101 years away from 1918. And then we are asked to solve for P of t, or the population of Arizona in 2019. We can substitute 101 for t in the equation to solve and get 7,351,787 as the population of Arizona in 2019. The next way we will solve this problem is to use a graph. In the graph, we have plotted the equation we came up with earlier, as well as a line at y equals 10 million. The x-coordinate of the point that the two lines intersect at is 110.913, which we can round up to 111 years, which is the same answer we got for part 1 when we used an equation. For part 2, we have plotted the same base equation as well as a line at x equals 101, as that is how many years that have passed between 1918 and 2019. The y-coordinate, which represents the population in 2019 of the point that the two lines intersect at, is 7,351,787, which again is the same answer we got for part 2 when we used an equation. The third way we can solve this problem is by using a data table. Due to lack of space, this data table does not have all the values for this problem, but instead I have chosen to present the most valuable ones. As you can see, 111 years from 1918 is when the population is closest to 10 million, which means that 2029 is when Arizona's population will hit 10 million. The data table value once again proves our answer for part 1 is accurate, as that is the same value we got when we solved using the equation and the graph. Similarly, for part 2, 2019 is 101 years away from 1918, and the population then, shown in the data table, is 7,351,787, which is the same answer we got when we solved using the equation and graph. Thank you so much for watching, and I hope you enjoyed this video.